All right, let's get started with chapter 6. This is a really different kind of topic than what we've been doing in chapters 4 and 5. This is mostly going to be more of a skill sort of section, and actually all of chapter 6 is more of like a algebra skills where you need to use simple algebra rules to do more complicated things, but there's not a lot of concepts here. So, and not a lot of word problems either. So mostly we're going to be practicing some algebra skills. But first, let's try to understand where some of these algebra rules about exponents come from. So first of all, remember integer just means whole numbers, including negative numbers, and we want to see what happens when you have negative numbers and exponents. But first, I just want to do a quick review of what positive integer exponents mean. They mean repeated multiplication. So for example, 2 and 3 are examples of positive integers. So if you have an exponent of 2, it just means multiply something by itself 2 times. So really, 4a to the power 2 times b to the power 3 really means, it's just a shorter way of writing 4 times a times a times b times b times b, like so. And if you have something like this, where the whole thing is raised to the power 3, that means the base of the exponent is this 5x squared thing, so that's what we're going to write 3 times. So this means 5x squared times 5x squared times 5x squared, and that you could also just write the x's 2 times each if you wanted. So whenever you have something with positive integer exponents, it's really just a shortened way of writing out the whole thing multiplied some number of times together. And keep in mind that the base of the exponent is, if it's in parentheses like this, the base of this exponent is everything in parentheses. But if you don't have parentheses around the whole thing, then like the base of the exponent 2 is just a, and the base of the exponent 3 is just b. So you're not doing like 4 times itself. There's only one copy of 4 here. Okay, so that's what positive integer exponents mean. What does it mean when you have a negative integer exponent? So to figure out what negative integer exponents should mean, let's think about the positive integers first, and we're going to see what the pattern is here, and we're going to make it so the pattern that these things work with, we want that to work with negative integers too. So we're going to go backwards to figure out what should 2 to the power 0 be, what should 2 to the power negative 1 be, and what should 2 to the power negative 3 be, so that this pattern keeps going on. So of course 2 to the power 1 is just 2, 2 to the power 2 is 4, 2 to the power 3 means 2 times 2 times 2, which is 8, etc. And let's think about what happens every time you go to the right. Every time you go to the right here, from 2 to 4, or from 4 to 8, or from 8 to 16, it's really like you're multiplying by 2. So it's like 2 times another 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. And what I want to do is also see what happens when you go backwards here. So what do you do to 8, or excuse me, what do you do to 16 to get 8? You divide it by 2. What do you do to 8 to get 4? It's just the opposite of multiplying by 2, so we're going to divide that by 2. And what do you do to 4 to get 2? You divide it by 2. And in order to see what 2 to the power 0 should be so that we can make this pattern keep going, we're just going to say, let's keep dividing this by 2. So 2 divided by 2 is 1. And then we're going to keep going. If we divide that by 2, 1 divided by 2 is also known as 1/2. 1 divided by 2, like so. And if we divide that by 2, 1, oh, whoops, this should be a -2 there. 1/2 divided by 2 becomes 1/4. And you could also check when you see this that when you go from left to right, you're still doing the same thing we were doing before. We're still multiplying by 2. So 1/2 times 2 is 1, and 1/4 times 2 is 1/2. So this is still multiplication by 2. So this pattern is going to make a lot of the algebra stuff we do possible that wouldn't be possible otherwise. So that's going to be our definition of negative exponents. So when you have, for example, 2 to the power -1, really it means 1 divided by 2, because the negative sort of means like the opposite of multiplying by 2. Or 2 to the -2 should be 1 divided by 2 to the power 2. And that's what this says here. If you have any number that is not equal to 0 to a negative exponent, that is really going to be a short way of writing 1 over that a to that positive n. So here's a quick example where we can try this. I want to take each of these expressions and write them without negative exponents. I recommend you pause this right now to try it yourself. It should be pretty quick. And now that you've paused it, I'm going to start doing, and now that you've paused it and you're starting it again, I'm going to start doing the problem here. So here we have a -4 exponent, and the base of this -4 exponent, the thing being raised to the power -4, is just x. So the -4 does not affect the number 3. So I'm going to write this as 3, and then the x to the -4 is what we're going to use this rule with. That's going to become 1 over x to the power 4. And this, 3 is really just 3 over 1, right? So you could just write this as 3 over x to the power 4. It's kind of a simpler way to write that. There's my ugly 4. Okay. This time, the base of the -4 exponent is the entire 3x thing. So it's like the a in the definition here is now 3x, not just x. So this one's going to turn into 1 over 3x to the 4th power. And you could just leave it like that. If you want, now that there's a positive exponent and you know what positive exponents mean, you could write this as 1 over 3x times 3x times 3x times 3x, and write that as, if you multiply all the 3's together, 3 times 3 times 3 times 3 is 81, and then all the x's multiplied, x times x times x times x, is just x to the 4th. So you could write it like this too. It's kind of a little simpler, I think. Okay, let's look at this one now. Here you have an x to the -3, so I'm going to rewrite that as 1 over x to the positive 3, and then x to the positive 3 here is just that x to the positive 3. And you can see that these are going to cancel out, so you just get the number 1. So this is actually the same thing, by the way, as x to the power 0. This is a thing, I didn't mention it before, but it's written right here. Any number raised to the power 0 is always 1. So x to the 0 in general is always 1. All right, here's a quick exercise for you to do to get a little bit of practice. This section and chapter 6 in general It's really all about practice, practice, practice. There's not so many weird new mathematical concepts or language. We just need to do a lot of these exercises until you're proficient at it. And good luck with that. And remember, the answers to the exercises are always in the book, and you should check them to make sure that you're doing it right and not just practicing bad habits, because that's even worse than not practicing at all. So good luck with that, and I'll see you in the next video.